Hey there, Ravens. Welcome back to episode number 6. We are going to talk about Charles's law, volume, and temperature. All right, so he looked at volume of a given amount of gas, so same number of moles at a constant pressure, and it increases with the temperature of the gas. So as the particles start moving faster, they take up more space because if allowed. Okay, so volume and temperature are graphed in a straight line. It forms a linear direct line. Okay, we have to look at temperature. All right, here is a graph that explains, and let me go through so you can actually see the graph. There it is. All right, so you'll notice if we extrapolate the data, it all comes down to, where's my mouse so you guys can see it? Over here, negative 273 degrees Celsius. That's the lowest possible temperature attainable because you can't have negative volume. So if particles stop moving completely, okay, that's going to be the lowest possible value that we can get. Okay, so we need to use Kelvins, all right? So writing the equations for the graph, we don't need negative values. We use the Kelvin scale whenever we are using gas laws. And the Kelvin scale, as I said, has no negative values. So to convert from degrees Celsius to Kelvins, you're just going to add 273 to it. And that gives you the number of Kelvins. So, for example, we'll go to our pen. 25 degrees Celsius plus 273 is going to equal 298 kelvins. Okay, so you're going to have to do this a lot. Every time you see temperature, automatically, first thing you do, convert to kelvins. Add 273 to it. If this is a negative number, that's going to decrease. If it's positive, it'll go higher than 273. All right, and that, let's go back to our arrow, is all we need to know about kelvins, and we'll just apply that knowledge as we go through from here. Okay. All right, so volume and temperature are directly proportional. If one increases, the other increases by the same proportion. And again, just like Boyle's law, I don't care if you remember that it is Charles who did this. Okay, Jacques Charles, just remember what I have highlighted here. Volume and temperature are directly proportional. If the temperature goes up, the volume goes up. If the volume goes down, the temperature is going down. Okay, another way to state Charles's law is this way. V1 over T1 is equal to V2 over T2. Pressure and amount of gas must remain constant. Okay, so here is an example problem, and we have, let me look at my notes here. There are 2 example problems, so I'm going to do those in the next episode. Okay, see you soon.